All right, here we go. So we are still in chapter 5. We are. So then again, this was systems. Probably about 3 or 4. It's gonna take a question a page. It's a process. It's not, I wouldn't say hard, but solving for 3 different variables can be tedious. When I teach you the systems or the matrices, which I think is next week, this process has become a lot easier. Front and back, so that's 6. You might be able to make it to the end of the week. System of equations and inequalities, we are going to be in section 5.2, which is actually systems of linear No, ma'am, I would make my own. Yeah. If I was to make this like on my own with no one in the classroom, I might use them. But it doesn't flow really well. Like this right here, if I gave this to the next semester, they'd be like, what is he talking about? No, the conversation I'm having with you, they're going to be hearing it too. Well, no, I do it with y'all because y'all understand. I wouldn't do it with my other classes, like another class I have. 3. So again, we're going to be solving linear equations in 3 variables and applications. We're feeling some algebra today. All right, number 1. All right, so here we go. So again, just like in a 2 variable, the answer is an ordered pair. In a 3 variable, it's still an ordered pair, but of 3. Pair not being 3. What's that? It's x comma y comma z. Is that still ordered pair? It's 3. I don't know. That order few. On what? What was the question? X comma y. Like an ordered pair. That's how. Is x comma y. I gave you a 3 variable equation in the homework already? I don't know. Let me know. 5.2 should have been 3 variable. Alrighty, so this is the process. You want to pick 2 equations in which you can do the addition elimination method, and then you'll take one of the equations to solve for one of the letters, and then you will back substitute in. Actually, no, there's an easier way. Scratch that. Just solve for one of the letters. Pick an equation and solve for a letter. Which one do you want? The second one? All right. What about the second one? What letter in the second one do you want me to solve? All right, and it doesn't matter which one. All right, so we'll solve for the x for the second one. So I get x equals 9 plus 2z minus y, right? Okay. Now pick another equation and you want to then substitute that in there. Which one, first or second? Okay. When I do that, I end up getting 2 parentheses 9 plus 2z minus y minus 3y plus z equals negative 12. And you also want to make sure you give yourself plenty of room. Oh no, I want the whole thing. Yeah, this whole thing. No. There we go. Okay. Okay. Woo, that was weird. All right. So what we want to do then is just basically, again, distribute and then solve for another letter. Which one do you want to solve for? Y or Z? Okay. Sounds good. Doesn't matter. So then I get 18 plus 4z minus 2y minus 3y plus z equals negative 12. If I combine like terms, it looks like I will get a 18 plus 5z minus 5y equals negative 12. I forgot what you asked me to solve for. 0y. Y, okay. So I'm going to move everything over. So then I'm going to need another page here in a second. But that's going to be negative 5y equals negative 12 minus 18 minus 5z, because negative 2y minus 3y gives you negative 5y. Right? And I'm going to combine like terms. That will give me negative 30 minus 5z. That's what negative 5y would equal. Then I would do what? Divide by 5. So then I get y equals 6 plus z. Correct? Okay. I'm going to have to, yeah. But I might not. I don't know. Because what I have to do now is I now need to take this, plug it into this equation so that my x equation has a z, my y equation will have a z, and then I have to plug it into the third equation, so then I have nothing but z's. Yep. Okay, so step one, I solved for a random letter. Didn't matter which one. Y'all chose the second equation, x, so I did that. Then I asked y'all to pick out of the other two equations which one you want to plug in. Y'all said the first one, so I plugged that in for my x. Then I got to this point here, and I asked y'all what letter you want to solve for. Again, doesn't matter. Y'all said y, so I just solved for that. Now that I've done all that, I got to get it down to where I can get an equation with only one variable. It's the only thing I know how to solve. So I got to take this equation, back substitute it into what x equals so that I get an equation with only z's in it. Then take this equation of y, the new equation for x, back substitute it into the equation I have not used yet so that I can get my y, or my z, or in this case. And then once I get my z, then I can easily go find my x and y. Okay, let's do it. So again, I'm going to take this guy and I'm going to substitute it in for my y right here. When I do that, I get x equals 9 plus 2z minus 6 plus z. The x equals this. I have an x equals equation with only a z now. Because now this becomes 9 plus 2z minus 6 minus z, which just ends up being, what's that, just z plus 3? So now what we've just created. Okay. So now what we created is we created an equation for y that has a z in it, only a z. We created an equation of x that only has a z in it. So now I can replace x and y so that this whole thing will only have a z. And now I can solve something with only one variable. And this is at the point where now I'm going to have to change slides because I'm running out of room. Okay. I also now depend on y'all to know what those equations were. I'll go back. Sorry. So again, what I'm about to do is I'm going to take my y equation and my x equation, and I'm going to plug it into the equation I have not used yet, which in this situation is the last one. Now, what's really cool about this process, it doesn't matter where you originally start. I could have used the first equation, the last equation, but I'll be substituting into the equation I have not used yet. Okay. So there might be like 32 different ways to get there. So we're good. Okay. So I'm going to take that last equation, which was negative 3x plus 2y minus z equals 7. That's right. Now I'm going to replace x and y with the two equations that we just came up with. So that was negative 3, z plus 3. So that's z plus 3 plus 2. Was that z plus 6? What was y? 6 plus z, or same thing. 6 plus z minus z equals 7. So now look. So now I have an equation with only one letter. We know how to solve this. I'm going to distribute. So I guess 6 plus z, yes. Because it looks like 2. That's why I put a line through it. So that's negative 3z minus 6. You're correct. Plus 12 plus 2z minus z equals 7. Now what? So negative 3z plus 2z is negative z minus another z would give me negative 2z. Negative 9 plus 12 is 3. What would I do now? So the negative 2z. Is that 4? And then z would equal negative 2. So I found my z. Now that I know z is equal to negative 2, I can come back and I can find out all my x's and y's. Because now that I know z is negative 2, what's negative 2 plus 3? 1. That's what x equals. Come back over here. What's 6 plus negative 2? That's what y equals. So my final answer would just be 1, 4, negative 2. It did. Okay. Well, maybe we can have some time. We can look at that for homework. So again, in my opinion, I don't think it's a hard process. I just think it's a long process, lengthy for just one answer. Now, when I teach you matrices, it becomes a little bit easier, but you're really kind of doing the same math without letters and just dealing with numbers. All right, so we're all good there? Okay, we're not, you just writing it down or you had a question? I have 1, 2, 3, 4, 5, 6, 7. 7 more questions I have on the booklet. We might not get to all of them. I think at least 4 or 5. Because what time we got here? Because I want to make sure I hit the word problems. So that's 41. So as long as I get to 11:30, I move on to a word problem. I think we'll be okay. Because after this, now we're just going to go through the process again, repeatedly and repeatedly. Yeah, we can do one more time. We'll skip to a word problem, then just come back and do more. All right, so that's object. Oh, I forgot to write that, but this was objective 1. I don't know if you want to add that in there. Objective 1, which was I did this a whole different way. This objective was supposed to be identify solutions. I got so excited, I jumped the gun. Yep, to a system of linear equations in 3 variables. You'll see this in the video. But the question was, all I needed to do on this one was just determine, is 2 comma 5 comma -1 the answer? No. And what you could have done is just literally just plugged it in. The other one was, is 1 comma 4 comma -2 the answer? Obviously, we just did the work, but yes. And what you would do if you want to go through this whole process for this type of question is you would just plug it in and see if it's true or false. The second objective is doing what we just did, so that's good. So we'll just do another one. So in objective 2, there's no, that's a J. All right, objective 2 is to solve systems of linear equations in 3 variables. I know. So now we're going to do what we've actually already done. I guess I'll stay in pink, but here's example number 2. 3x equals 5y. That's a 5 minus z plus 13, negative parentheses x minus y minus z equals x minus 3, 5 parentheses x plus y equals 3y minus 3z minus 4. Yeah, basically. There's a couple options you can do here. If you like to see these guys in standard form, you go ahead and distribute, combine like terms, get your x, y, and z to one side, your constant to the other. Does not matter. Or you can go straight into the process in which you're just looking at all 3 equations and solving for a letter. Well, when I look at this, most students want to go, oh, I'll just solve for x, is just one step. But then what am I going to deal with the whole time? I don't want to deal with fractions. I want to solve for a letter that doesn't have anything next to it. So in this case, I would either solve for this z, this x. It doesn't really matter, but I would solve for something that doesn't really have a number next to it. I wouldn't know. But really and truly, it's whatever your organizational skills need. Solve for z? Okay, that works. And it doesn't matter. Again, you can put it in standard form. It doesn't really matter. There's no wrong way to go about starting this. Use brown. Have you ever used brown? Okay. So we decided we're going to solve for z. Okay, so I'm going to write it as z equals 3x minus 5. Oh, you're right. It does have a negative. So that would be negative 3x plus 5y minus 13 plus 13. Basically, I just moved the z over and moved the 3x over and left everything else over there. I didn't even see the fact that that was a negative z. All right, so we're good there. What was step 2? Which one do you want me to plug it into? I would say second. I've now learned from my last time. I just need to put this as a side note. So negative x minus y minus negative 3x plus 5y plus 13 equals x minus 3. And then, yeah, then just distribute. So this would just be negative x plus y plus 3x minus 5y minus 13 equals x minus 3, correct? All I did was just distribute a negative. Now I'm going to do a whole bunch of combining. I see negative x plus 3x. I see a 2x minus 4y minus 13 equals x minus 3. I'm going to stop here because now my question to you is, what am I solving for, an x or a y? Okay. So I need to get all my x's to one side. So I don't know how, y'all want to move this over and get a negative, then go back and change the signs? Or do you want to move this over and then move everything else over there? What's y'all's approach? Yeah. Okay. So I'll subtract it. So that will give me an x. So I subtracted the x over here. So 2x minus x gives me x. And then I have a positive 4y and then a 13 plus negative 3, which will give me 10. Are we all good on how that became 4y plus 10, or do I need to write out the entire process? Okay. If you need to write it, by all means, you do what you got to do, but I'm running out of room. All right, so now I got an x equation. So what's the next step? Plug it into the next one. Sorry, my bad. Do I plug it into the next one? What's good? I need to plug it in back to the other letter so I can get two equations with the same letter. So I'm going to take this x and I'm going to plug it in here so that I get two equations that have nothing but y's in them. All right, so when I do that, that will now become negative 3. Can y'all see that color? I know we just talked about all of us having bad vision, so we're just going to go with a darker color here. So that's going to be negative 3 and then 4y plus 10 plus 5y plus 13. Right? And then I'll just distribute and simplify. That's negative 12y minus 30 plus 5y plus 13. And then I get what, negative 7y minus 17. So we all got. And again, that's what my z would be. So we're all good. Everyone checked it. Right. So now that I have two equations that have nothing but a y, I can now go to the equation I have not used yet, substitute it in, so then I have an equation that has nothing but y's. Okay. Does that brown and green look the same to y'all? To me, they're like really close. I'm like, is that a different color? Maybe, I don't know. To me, like, if I didn't know I switched colors here and I'm just writing these notes down, it looks like it's the same color. Yes. Yes, that's what I see. They both kind of look black to me. Huh? Oh, you know what? It actually looks different here. Here, it looks black. There, it looks like actually, but even then, maybe if I looked way back there, but I don't know. Regardless, beside the point. All right, so this becomes then 5. My x is going to be 4y plus 10 plus y equals 3y minus 3 times negative 7y minus 17 minus 4. And again, we did all of that work. So now I have an equation with nothing but y's in which I can solve. We still good? All right, so let's go through the process. So now I get 20y plus 50 plus 5y equals 3y plus 21y plus 51. 51 minus 4. Combine like terms and now get 25y plus 50 equals 24y 30 or 47. Alrighty, I'm actually gonna move all these y's here because if I take 24 minus 25, I'm left with just a y. Subtract 50 over there, that just gives me a straight up negative 3. Okay. Did I make a mistake? I plugged in that one and that one, right? Yeah, you're good. You're at the same step I'm at. Oh, you just started. Yeah, after at that point, then I combined like terms, then I moved over. You're at this step. Oh, are you? Let me see.
I must have messed up the equation in the first place.
There's the 5y.
Okay.
No, that's good. Hold on. Where do we plug into? Oh, we plugged in. Where'd my 5y come from? Oh, because I plugged it. Oh, because it's x plus y. So it's 4y plus 10 plus y because it's an x plus y in that parentheses. And that's how I got the 5y when I distributed it. All right, and then after that, we can just back substitute in. So this gives me -7 times -3 minus 17, which is 21 minus 17, which is 4. 4 times -3 plus 10 would be -12 plus 10, which is -2. So then I get, and again, this is alphabetical order. So my x would be -2, my y is -3, and my z is 4. I'm sure you already figured that out, but the answers need to be in alphabetical order. So x, y, z is the order. What are you talking about? The answer? I figured out what x was. Yeah, yeah. And because you already developed two equations with just a y in it, it makes plugging in those steps a lot quicker. It's gray. Nice. And then also, just like in the other answer, what if at some point I did all of this work and I got -3 equals -3 here? What would that mean? Infinitely many solutions. What kind of answer is that? Dependent. Dependent. If it's infinitely many, it's dependent. What if I would have got 0 equals -3 at this stage? Then it'd be no solution and it's inconsistent. All right, so you would figure that out at the very, well, at this point here. No, no, I just know on the homework, I would more want no solution or infinitely many solutions. Yes, and you wouldn't figure that out until the third step when you're solving for that last letter, because other than that, everything will still give you equations until the end. All right. All right, so let's go ahead and skip to objective 3. Let's do at least one word prob, and then we'll go back and we'll practice some more of these. Yes, ma'am. Why is white even a color? What? No, I mean, it's a white background. Oh my gosh, y'all just take things out of context. But I don't even know how to do that. What's this button do? Yeah. Free pancake thing. Oh, I see. This moves it. Oh, I have a laser. How do you do that? It's an eraser. What am I dropping? That's an eraser. It's a smart pen. I feel like that was a waste of time. Now we can use whites. All that effort. You know what this reminds me of? You ever watch those YouTube videos of the math guy that does all the highlight? Yeah. He saved me so much in college. Oh. I don't know his name, but I know his voice. Like if he just started talking like, you're the guy that makes the videos. I have no idea. All right, we're just gonna use systems of linear equations in applications. I feel like I'm using an eraser in this. I remember in art class, I think it was 8th grade, we drew we drew a picture, painted it black, then scratched out another picture on top of that picture. That was the coolest thing I ever did. Oh, you did? Oh, so yeah, yes. So you can, and then you make another picture on. Yes, okay, that's still a thing. See, that was so cool. That's the only thing I remember in art. Okay, I do not feel like writing this entire word problem, so I'm going to read it to you. Perry inherited $120,000 from his uncle and decided to invest the money. That's a good idea. All right. He put part of the money in a money market account that earns 2.2% simple interest. Just part of it. So we don't know how much. So that's 2.2, and we'll just say X for part of that amount. We don't know how much amount. The remaining money was invested in a stock stock that returned 6% in the first year. So this would technically be like 120 minus whatever that amount is left. And a mutual fund. Oh, no. Because we don't know. We just know that the rest of the amount was put in a stock and a mutual fund. Mutual fund that lost 2% in the first year. He invested, oh my goodness. He invested $10,000 more in the stock than he did in the mutual fund. So that means stock would be 10,000 plus whatever. Oh my goodness, I got to write this correctly. So it was, he put $10,000 more in the stock than he did in the mutual fund. And his net gain was $2,820 in the first year. He gained money. Net is a gain. Determine the amount invested in each account. Okay. So here's my approach. You have X plus Y plus Z has to equal what? 200,000 or 120,000, right? Okay. Then we know whatever these amounts were, 0.022x plus 0.06, right? 1, 2, yeah. Y minus 0.02z, net worth 2,820. But then it also gave us this tidbit of advice. So there's our third equation, which happens to already be solved for a y. So now just figure out which one you want to substitute it in to solve for the other letter. First one, I agree. Yes. Very good point. My heart dropped because I was like, I am not writing this all again. If I erase the background. I don't know. You don't know how to do that yet. So this right here then would just be X plus 10,000. Man, my heart is like high right now. Whew. Feel like I just like my computer just crashed on my 400-word essay or something like that, and I forgot to auto save it. Actually, so that was before like auto save. Oh, that's not fun. All right, what letter do you want me to solve for? I plugged in what Y is from this equation when it said that they put $10,000 more in the stock than they did the mutual fund. So that's how I was able to establish this equation. So then I took that, plugged it in for Y because y'all told me to put it in the first equation. Now my question to you is, what letter do you want me to solve for? X, okay. So now I get X equals 100 and back 110,000 minus 2z. Now what's cool about this is that my original first equation is already an equation with just a z. So I don't have to back substitute this in to get an equation with just a z. So that does save me a little time. But I now have two equations with just a z. I can now plug it in to solve for z. All right? Huh? I would plug it into this equation. So this would be 0.022 times 110,000. Yes, ma'am. Minus 2z plus 0.06 times 10,000 plus z minus 0.02z equals 2,820. I have now officially ran out of room. So do y'all have this written down? Because I'm going to have to move to a new page. Yeah, we're on white. I do like the black background though. Ooh, but it doesn't have a zoom in button. Like the TV has that zoom in button, but this doesn't have a zoom in. What is it? On top of it? Oh, no. No. Are we ready? It'll go away. I'm gonna do black and then I'm gonna put like a different color on it so I can act like I'm that guy. It does all the little things. Everyone ready? You gonna leave that? Okay. I don't have a teal. I have an ice blue, which is pretty close. Okay, I don't remember the equation. Thank you. All right, so then we go through the distributing process. Matthew, looked like you were on top of it. What's 0.022 times 110,000? What? 2,420, right? Okay, I thought you were saying 24,000. I was like, that seems a little big. All right, so 20,000, 2,420 minus 0.044 Z plus 600 plus 0.06 Z minus 0.02 Z equals 2,820. Negative 0.044, negative 0.064. So would that be negative 0.04? Yeah. 0.004, right? Because negative 0.044Z and negative 0.02 would be negative 0.064. Add that to that, that should then be just negative 0.004, right? Or am I putting too many zeros? Okay. Yeah, that's combining like terms. And then I have 3,020 equals 2,820. Subtract that over, so I now get, my old age is kicking in. This is starting to hurt my eyes. Is that 200? Negative 200? I need a second. You're my second? Okay. And then divide that by 0.004. So it's going to be a positive. So that would be 1, 2, 3. That'd be 200,000 divided by 4. 50,000? 50,000? Because you're dividing by a decimal. So you got to think of it like how many 4/10 of a penny can you put in 200 bucks? That's what I did. I moved it and I made it 200,000 divided by 4 in my head. All right, so then that's Z. So that would be my mutual fund. What's Z? Mutual fund. Yeah, this is step 1. I'm just kidding. This is like step 7. So this is $50,000 on my mutual fund. And if my stock was 10,000 more than my mutual fund, that would be 60,000 on my stock. What was the other one called? Money market. Okay. And then for my money market, that would be 110. Because it's a word problem, yes, ma'am. That's correct. You wouldn't put it in a ordered pair. How much is it? Was it not? Was it 120? Okay, my bad. In my head, I thought it was 220. Yeah, so that's just 10,000. I thought the original amount was 220. I don't know where I got that from. Money market. We get it out 41. Okay, it's a good place to stop. The rest of them are just gonna be more examples. Does everyone have it written down before I hit the stop button? Because it's gonna be a little thing. We did 3